Hey girls and boys, it's Mr. McAndrew, and this is the moment I've been waiting for. We get to dive into multi-digit multiplication. Now we've been doing that all week, but we've been really focusing on multiplying by 10, by 100, by 1,000. Yesterday, you did a lot of work with multiplying by 100. You're going to see why this is so important when we get to multiplying things like 384 times 5, okay? Let's review the work from yesterday first, so you can check your work. So take out your work from yesterday, should have said Wednesday, practice pages 1, 2, and 3, and then we'll dive in, okay? All right, so here we are. So how do we do? So here, you can see that we have 2 times 300. Okay, so we have 300 once, 300 twice, which is the same as saying 2 times 3 gives us 600. 6 times 100 is 600. Okay? All right. Down here we have 5 groups of 500, or 5 times 500s. So 1 times 500, 2 times 500, 3 times, 4 times, 5 times 500. So that gives us 5 times 5 gives us 25. Not just 25, 25 hundreds. So multiply that by 100 and we get 2,500. So our answer is 2,500 or 2,500. Okay? All right, how did you guys do on that so far? Do all right? I do expect you to do this work and do it to the best of your ability. If you get confused, you can watch the video again. And if you make mistakes, but you did your best, that's totally fine. Let's see, here we have 400 times 6. Okay, so we have 400 6 times. Once, twice, 3 times, 4 times, 5 times, 6 times. All right, so again, we have, let's see, we have 6 groups of 4, or 4 times 6, 6 times 4, same thing. So that gives us 2,400s. All right, 6 times 4 is 24, times 100 is 2,400. Okay, 2,000 or 2,400. This one, you have 700 3 times, 1, 2, 3. That's 2,100. Oops, I put my comma in the wrong place. It goes there. Okay, so 2,100. 3 times 7 is 21, times 100 is 2,100. Okay, 2 zeros, 2 zeros. All right. Last page looks like this. Okay. All right, so I want you to notice something. There is a method to my madness sometimes. I'm putting what you did on Tuesday over here, okay, because it's exactly the same problems, just that over here you were multiplying by like 80, multiples of 10. Here you're multiplying by multiples of 100, like 800. So if we look, boys and girls, okay, girls and boys, boys and girls, 7 times 8 is 56, 7 times 8. 7 times 80 is 560. 7 times 800 is 5,600. So you can see how this works, right? 7 times 80, 56 with a 0, 56 with 2 zeros. Here we have 4 times 2 is 8, right? 4 times 2 is 8. But if it's 4 times 20, that's 2 tens, which means we have to add a 0, so it's 80. 4 times 200 is 800. So 2 zeros, sorry, wrong color. 2 zeros here, 2 zeros here. 4 times 2 is 8. Okay, and you can see that all the way down. 6 times 30 is 180. 6 times 300 is 1,800. So I'm going to say it a little bit differently this time. 6 times 30 is 18 tens, right? 6 times 300 is 18 hundreds. 2 times 80 is 16 tens. 2 times 800 is 16 hundredths. So that's another way of thinking about it. All right, and here we have 60 times 2 is 120, or you have 12 tens. 600 times 2, you have 6 times 2 is 12, but you're dealing with 12 hundreds. So you have 1200, 1200. And the last one, 50 times 3 is 150, or 15 tens. 500 times 3 is 15 hundredths. Okay, hopefully you're getting the idea here, because we're going to use this information, this knowledge, to work on 2 by 1 digit multiplication. All right, so boys and girls, if you could take out your math packet, okay, you'll need it in a few minutes. For now, you just need to watch me, because I'm going to demo a few examples for you. So I take it back. You don't have to take out your math packet right now. You just, maybe in a few minutes once I'm done. Or you could take it out now and then proceed with the video. It's up to you. So I want you to think back to Monday when I had out the square inch tiles and I was talking about the distributive property. Remember that? We said sometimes you don't know the answer to a problem. Like, look at this. This says 5 times 15. This is not a multiple of 10 or 100. Like, I don't know what that is. But the distributive property says we can split apart, okay, or break apart the problem to break it into easier problems. So we're going to break this into 2 easier problems and then add them back together again. Does that make sense? Okay, so to help you understand this, I'm going to use a math app that I discovered called Partial Product Finder. I know, it's a mouthful, but you'll see. So I'm going to, and here's how it works. It already says 5 here. I just click here, and you're also going to be using this, so pay attention, please. And then I put in 15, and then I say make. Whoa, look, and it makes a rectangle that is 5, right? 5 rows on the side here. 1, 2, 3, 4, 5. And then along the top, it's got 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the question is, how are we going to split it up? Right? Now, we know from the distributive property you can break it up any way you want. So watch, I can take this slider and I can put it anywhere. Look, put it here. Okay, and now look, this shows that this rectangle is 5 times 6, 5 rows of 6. Okay, so 5 rows of 6. And I'm going to, over here, you see where it says answer? I'm going to click on it so it shows me the answer. I don't care for you to look. It's fine for you to look at the answer. It's good. So it shows me that 5 times 6 is 30, and 5 times 9 is 45. This is 5 times 6 because it's 5 rows of 6. 1, 2, 3, 4, 5. 5 rows of 6, and there's 1, 2, 3, 4, 5, 6 tiles in each row. So that's 30, and over here I have 5 times 9, which I know is 45. So if I don't know what 5 times 15 is, I can say, okay, well, let's do 5 times 6, which is 30, add it to 5 times 9, 5 rows of 9, which is 45, and I get 75 is my answer. Do you see 75 right there? Now I can put this in a different spot. Okay, I'm going to put it right here. Because now I have 5 times 10. Remember doing that on Monday? 5 times 10? We know that's easy peasy, right? That's 50. And it shows us on the computer screen, it's 50. And then we have 5 times 5, which if you don't know is okay. You need to get out your multiplication chart. Okay? But in this case, it tells you 25. So 50 plus 25 is also 75. Now I can move this thing anywhere I want. I can put it way over here. And this tells me that 5 rows of 13 is 65 plus 5 rows of 2 is 10. It still gives me 75. But here's what I want to say to you, boys and girls. What we are going to be doing is we're going to use expanded notation to split up these rectangles. Say what, Mr. McAndrew? You heard me. So, what I'm saying is, when you have 15, okay, let's go back to my paper over here. When you have 15, we're going to break it. So here we have, let's use a different color. Here we have 5. Okay, up here we have 15. Expanded notation for 15 would be 15 equals 10 plus 5. It's the value of the tens place, which is 10, plus the value of the ones place. We've been doing this throughout the year, right? You guys have been doing this. Okay, so let's get my head out of the way. So what we would do is, I would count off 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I have this rectangle. So that's 5 rows of 10, okay, which gives me 50, like we just did on the computer. And here, so this is 10, and this is 5. And this rectangle is 5 rows of 5. So 5 rows of 5. I have 1 row of 5, 2, 3, 4. I have 5 rows of 5. And 5 times 5 is, again, my head is in the way, 5. Where am I going to put my head? Hold on a second. Let's make the screen bigger. All right, that's better. So this rectangle, right, this is 5 times 10, which is 50. 5 rows of 10. This rectangle is 5 rows of 5, which is 25. What's 50 plus 25? Well, that's not so hard. All right, I can do that. 50 plus 25, 5 is 75. Just like we saw on the computer. Okay? So, let's do another one because I want to make sure you're understanding what's going on here. Okay, so you don't have this problem in your packet. This is just what I'm going to show you. Okay, so look at this one. This is a big one. Look, this is 8 times 29. So we're using area model, right? So we know this is 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 rows of 29. Trust me, this row is 29. Boom. Okay? Now, we don't want to just split it up anywhere. We want to do it in a spot that's really helpful. Because I don't know what 8 times 29 is, do you? But I do know what 8 times 20 is. And remember, I said we're going to break up 29 using expanded notation. So 29 is equal to 20 plus 9. The 2 stands for 20, the 9 stands for 9. So that would be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. That should be right here. Okay, so this is 20, and this is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here I have 8 times 20, and here I have 8 rows of 9. So I broke up one big rectangle into 2 smaller rectangles, and then do 2 different multiplication problems that I can then add back together. So if we go back to the computer, we can see what this looks like. So I'm going to type in 8 times 29. That's not an 8, that's a 9. Mr. McAndrew, what are you doing, kid? Okay, so we have 8 times 29. I'm going to say make it. Whoa, that's a big one. I got to expand my screen. All right, so there we go. So we have 8 times 29, just like on our paper, right? On my paper. So I'm going to slide this all the way over to where it says 20. You see up here it says 20 and this says 9. Because that's expanded notation. 20 is the value of the 2 in the tens place, and 9 is in the ones place. Okay, so here you can see this is 8 times 20. Okay, and over here you've got 8 times 9. So on your paper, all right, your paper looks just like it does on the computer. You've got the parentheses, 8 times 20, and you've got the parentheses 8 times 9 with the actual product. Okay, So if I go back to my paper, so you can, boys and girls, what I'm saying is use this